So this is the last problem on VARIGNON'S principle. So in this problem also they are asking to find out the resultant magnitude of resultant and its position. So this is the given diagram 1.5. So about for this they want to calculate about this point A. They are asking to find out the magnitude of resultant and its position. So see here, a force of 200 Newton is acting at point D and making an angle 30 degrees. 200 Newton making an angle 30 degrees. And next, the force of 150 Newton is making an 45 degrees with the horizontal, and a moment of 100 Newton meter is acting at a distance of 3.5 meter from point A. So we need to find out the magnitude of resultant and its position. To do that, before we need to resolve this one to find out the summation of horizontal and vertical forces. So what are the steps involved? Let us list out the steps involved in calculation of these VARIGNON'S principle problems. So step number 1. What we are doing, if there are any forces are to be resolved in horizontal and vertical, we resolve them. Then second step is to find out summation of horizontal, summation of vertical and quadrant in which resultant is acting. Next, third step is to find out the magnitude of resultant and its angle theta. Then fourth step is application of the VARIGNON'S principle, that is moment produced by the resultant is equal to the moment produced by all other forces, that is R into R is equal to F1 into R1 plus F2 into R2. Upon simplification we get what is the perpendicular distance of this, the perpendicular distance of this resultant about a chosen point. That itself is the distance of the resultant, and here we have already got the magnitude of a resultant. So let us follow the things step by step now. So this is the point A chosen. From here at a distance of 2 meter and in the vertical distance 0.5 meter, a force of 150 Newton is acting. Here another force of 200 Newton at a distance of 2 plus 3 is 5 meter, and it is making an angle 30 degrees with the horizontal. First resolve this force. First step, resolve the forces. So see here, horizontal, to make a horizontal force it has to move upward. Agar it is moving along the given force, so this will be 200 cos 30 degrees. Next, the vertical force will act in the downward direction, and the resolved force is moving away from. The horizontal force was moving along the given theta, that's why we have caused here sine. So 200 sine 30 degrees. And here if we resolve this, it is a vertical. This vertical is moving away from the given angle theta, so this will be 150 sine 45 degrees, and this horizontal will be 150 cos 45 degrees. So first step of resolution of forces is done. Now calculate the summation of horizontal and summation of vertical. So summation of horizontal is equal to, so what are the horizontal forces? This is the horizontal force and this is the horizontal force. So both of the, sorry, this is not the horizontal force, this is the horizontal force. One force is acting in left hand side direction, another force is acting in right hand side direction. Right hand side direction positive, that is 200 cos 30 minus 150 cos 45 degrees. So summation of this horizontal forces is equal to 67.14 Newton. Now summation of vertical forces, this is one is the vertical force and this one is the vertical force. So this is acting in a downward direction, that's why minus 200 sine 30 degrees plus this is acting in upward direction, that is a positive 150 sine 45 degrees. So summation of vertical forces is equal to 306.07 Newton. So both the values are positive. So positive upward and positive right hand side. So the resultant will be acting in first quadrant only. So now we need to calculate the magnitude of resultant. Magnitude of resultant R is equal to under root of summation of horizontal square plus summation of vertical square, which is equal to under root of horizontal force is 67.14 square plus 306.07 square. So resultant magnitude of this resultant is equal to 313.35 Newton is the value of a resultant. And theta is equal to nothing but tan inverse of summation of vertical divided summation of vertical is 306.07 divided by 67.14. So theta will be equal to 77.63 degrees. This is the value of theta. So magnitude of this resultant is 313.35, and since it is positive, see here the symbol is positive, what I will do, I will measure the angle in anti-clockwise direction. This theta is equal to 77.63 degrees. This is the value of theta. So we have resultant, we have value of theta now. So this is acting in first quadrant. So let us assume the resultant is acting here. R is the resultant, and let this be the perpendicular distance R. So using VARIGNON'S principle to find out its position, we need to apply VARIGNON'S principle. So moment produced by this resultant is calculated by R into R, which is equal to the moment produced by all other forces. So like F1 R1 plus F2 R2, so on. How many forces are there? Those many we have to consider. So what is the resultant? Resultant is 313.35 is the resultant multiplied by the perpendicular distance R is equal to F1. Let us consider this force as F1. So see here, this force, if I transmit this force, I will change the color. If I transfer this force from here to here along its line of action, see here the force of 150 to 150 cos 45 is acting at a distance of 0.5 meters. So when I fix it here, see here, it will rotate in anti-clockwise. It will make this body to rotate in anti-clockwise direction. Due to application of force, it will start to rotate in anti-clockwise direction. So moment is calculated by force into perpendicular. What is the force? 150 cos 45, and perpendicular distance is 0.5 meter, and the moment acting is in anti-clockwise direction. That's why minus 150 cos 45 degrees multiplied by perpendicular distance 0.5. Next, let us consider this force. If I extend its line of action, so this is the perpendicular distance. 2 meter is the perpendicular from here to here. The perpendicular distance is 2 meters, right? This is the 2 meter is the perpendicular distance of this force. This force is acting in upward direction like this, right? So what happens? See here, this is the perpendicular distance and this is the direction in which force is acting. So this will make the body to rotate in again in anti-clockwise direction, right? This will make the body to rotate in anti-clockwise direction. So minus 150 sine 45. What is the perpendicular distance? Perpendicular distance is 2 meters. Next, let us come to this force. This force is acting in a downward direction. If I extend it here, this is the force is acting in like this, and perpendicular distance is from here to here. This is the perpendicular distance from chosen point. This is the chosen point. From here, this is the perpendicular distance, 2 meter plus 3 meter, 5 meter is the perpendicular distance, and due to application of this force, the body starts to rotate in clockwise direction like this. So 2 plus 3, 5 meter, plus what is the value, 200 sine 30 multiplied by 5. Now see here what I will do. Let me erase the other things. Okay, all other forces are done now. Only we are left with this force only. So I will extend this line of along. I will extend its line of action. So its line of action, if I extend it, this is the line of action. So I can transfer this 200 here. This is the force 200 cos 30 degrees. What is the perpendicular distance? Perpendicular distance will be equal to 1 meter, right? This is equal to this one, 1 meter. So what happens about this chosen point? This force will produce an clockwise moment, right? So plus 200 cos 30 multiplied by perpendicular distance 1. So this distance r, that apart from that, see here one more thing we are missing here. There is a moment is also acting here. So moment is directly a moment of 100 Newton meter is acting here. This moment is in clockwise direction. So don't get confused with this 3.5. There is no need of multiplying. Only when force is acting, we need to multiply perpendicular distance to know the moment. But here directly a moment, clockwise moment is acting. So add, since clockwise moment, I am directly adding it 100 Newton meter. If it was an anti-clockwise moment, would have taken it as a minus 100 Newton meter. Since it is a clockwise moment, I am taking it as plus 100. So now my resultant, the perpendicular distance of the resultant from the given point A is given by r is equal to, simplify these values, divided by 313.15. So upon simplification of these values, these will become 508.04 divided by 313.35. So perpendicular distance will come to be 1.62 meters. So this value is 1.62 meter. That is on this bar. So I will draw in simple. If this is the bar, given bar, about this point I want to know the, since it is making some angle, the resultant is acting at 1.62. That is, the resultant is acting here at a distance. So from here to here, what is the perpendicular distance? 1.62 meter, and this is making an angle of 77.63 degrees. This is the position where the resultant is acting, and the magnitude of this resultant is 313.35. In this manner, we have to calculate the distance and position of this result. So this is how they may give any different shapes, and upon that shape they will apply some forces, and they will ask to calculate what is the position of the resultant. So how to calculate? The steps are simple. First, if there are any inclined forces, resolve them, then find out horizontal and vertical, and know in which quadrant the resultant is acting, then find out the magnitude of resultant and angle theta by using these two formulas, and after that apply the Varignon's principle to know the position of this resultant. These are the clear steps involved to calculate the things. So kindly remember these steps, how to calculate the things, and whatever may be the shape of the diagram. And if any moment is given directly, if the clockwise moment, directly add here. If the anti-clockwise moment, directly subtract it. So this moment will come in picture only when Varignon's principle is applied. Till then, this moment has no effect on the given body to find out the magnitude of resultant and its direction. So kindly remember these steps. This is the last problem on Varignon's principle. If any other shapes, other modifications may be done for these problems. So problems which what the type of problems are to find out resultant magnitude and its position, to find out the equilibrium, and to find out the where the this resultant will cut the intercept on y-axis or intercept on x-axis. These are the three kinds of categories of a problem. So they may give different geometrical shapes to calculate the resultant and its position. Kindly remember all these steps and practice other problems.